So today I'm going to talk about containerized ASP.NET Core applications on Kubernetes. There was an ASP.NET Core talk this morning, I think. Maybe some of you guys went there. But I'll cover the basics here again. So in terms of my information, my name is Mete Atamel. This is my Twitter, my email, and my blog. I'm going to publish the slides on my Twitter afterwards, so if you want to just follow me, I'll publish the slides there. And if you have any feedback about my talk, there's a link. This link will be at the end of my talk as well. I always appreciate feedback about my talk. So in terms of the agenda, first we're going to talk about the .NET revolution, because in the last couple of years, there has been a lot of activity in the .NET world. So we'll just cover that briefly. Then I'm going to talk about containers. Why should you care about containers? What's special about them? And then once you have containers, you need to manage them. So we will get into Kubernetes. What is Kubernetes? What does it provide? And then finally, we'll look at the Kubernetes building blocks, the basic things that Kubernetes provides to you that will help you to manage containers. And throughout my talk, I will also try to show you demos. But I only have 40 minutes, so I might need to skip some of the demos. We'll see how it goes. All right, who are .NET developers here? Great, okay, that's good to see. In case you haven't realized, a lot of things haven't happened in .NET world in the last couple of years. So if you look at the world that we used to live in 2014, it was kind of like this. You had the open source world with the open source tools and languages. And some of the examples are, for the IDE, you would use Eclipse. For language, you would use like Java or Python or something else. And for database, you use MySQL, scripting, Bash. I mean, I haven't listed all of them here, but just to give you an idea, these were the main things. And then we had the Windows world that we lived in. And it was similar things, but slightly different. So instead of Java, we had C#, which is better than Java, right? Okay. I won't get into that. But then instead of Bash, we had PowerShell. Instead of MySQL, we had SQL Server. And actually, in my career, I started on the Windows side. And then at some point, I switched jobs. I had to go to the Linux side. And then at some point, I had to come back to Windows side. It was always frustrating for me because every single time, like you learn something, you get used to the shortcuts, you get used to the language, and then when you need to do the switch, if you have to do it, it's quite annoying because you're trying to do similar things, but it's slightly different that it takes you a little bit of time. And these two worlds, they didn't really interact up until recently, and that was really annoying. But since 2014, a lot of things have been happening. So first, .NET goes open source. Then in 2015, we started having the Linux tools coming to Windows and Windows tools coming to Linux. So OpenSSH comes to Windows, and then we had Ubuntu and Debian running in Azure Cloud. Then after that, the SQL Server, the flagship Microsoft Windows product, moves to Linux. We had PowerShell, scripting language moving to Linux, and then we had Bash, scripting language of Linux, coming to Windows. So that was kind of crazy. And then .NET, ASP.NET Core, which is the most exciting part for me, it's open source and it runs on Linux, Mac, and Windows. So all the time and effort you spend on building your knowledge on C# and .NET finally becomes available on Linux. And then the year ended with two announcements. Microsoft joining the Linux Foundation and Google joins the .NET Foundation. So I think it's been a crazy year in 2016. What this means for you is that now, we still have these two worlds, but the tools and the languages around it is converging. So all the things that you could do on Windows, now you can do them on the Linux, and then the stuff that you can do on Linux, more of them are becoming available on Windows. So for you, this is great, because this is a great time to be a .NET developer. All the time that we spent on learning .NET, building these frameworks, now they are finally, I think, paying off, and it's very exciting, at least for me. So that was the .NET revolution that we had in the last couple of years. Now, what I want to do right now is, first, I want to show you a simple ASP.NET Core application. We're going to build that really quickly, and then after that, I will take this app, containerize it using Docker, and then after that, we're going to deploy it to Kubernetes. So let's just build this application first. I have the video here because I wasn't sure how the Wi-Fi is going to be, so I'll just show you the video. So first, let me just pause for a second. What I'm using here is Google Cloud Platform, and in Google Cloud Platform, there's something called Cloud Shell, which is basically a shell running in your browser. And with that Cloud Shell, you got a development environment that you can actually do development within your browser. So that's what I'm using here. So let's just start. So what I'm doing here is I'm clicking on Start Cloud Shell. So this is basically giving me a Linux box in the cloud somewhere, and I can interact that Linux box from the browser. So I have the shell running in the browser. I have my home folder, and .NET. The .NET is the command line tool that's used to build ASP.NET Core applications. It's already installed in Cloud Shell. So what I'm going to do is I'm going to use .NET and create a simple web application using .NET. So first I create a folder. We call this folder Hello World ASP.NET Core, and then we cd into that folder. And then now what we're going to do is we're going to say .NET new -t web. So this gives us a skeleton web application that we're going to use to containerize and run on Kubernetes. So this created a bunch of files for me. And the main file, as you know, is the program.cs. So what I'm going to do is I'm going to make sure that my application starts on port 8080. So I just edit program.js, and then I'm going to add use URLs, and I'll make sure that it binds to port 8080. So that's what I'm doing here. I'm adding use URLs, HTTP, star, and 8080. So I do that, save. And then what we can do after that is we need to do .NET restore. So this restores the dependencies of your app. So it will look at project.json and look at all the dependencies, and it will download them from NuGet. So once this happens, we'll have all our dependencies. And then from there, we're going to run .NET run. So this will run our application. And all of this stuff is happening in Linux right now. I mean, if you told me this 2-3 years ago, I would tell you that you're crazy. And the fact that this is happening is huge for me. So now we have the dependencies. Now we're going to do .NET run. This will compile the application, and then it will run it, and then we will preview the application within the browser, make sure that it works. So as you can see, this is a very simple application, nothing fancy, but we will use this app and containerize it later to show you what I mean. So I preview the application, and this will open the web application. This is the default ASP.NET Core web application. It's running in the cloud already, okay? So it literally takes 1 minute to create this app and make it run in the cloud, okay? So this is the app that we're gonna use. So let me go back to my presentation. All right, so let's talk about containers now. Who is using containers today? Okay, so most of you guys, a good chunk of you guys do know about this. Let's just talk about them quickly so we know what containers are and why they're useful. So what is a container? Depending on who you ask, you get different definitions. But for me, a container is a lightweight way of virtualizing your applications, okay? That's all it is. It started with Linux, so it's a Linux process that's lightweight, so it starts really fast. It's sealed and isolated, so you can have multiple containers running on the same machine, but they're sealed from each other. They don't step on each other. Oops, sorry. They are easily deployable, so they start really fast. They're introspectable, so you can actually, when a container is running on your machine, you can get into it and see what's happening. And they're composable. To me, that's really important. So what you can have is you can have a base image that you depend on, and you can build on your images on top of them. So all the dependencies that you have, you can layer on top of each other. And this is really important because if you depend on something, all you need to do is depend this image, and this image has other dependencies, but you don't really care. You just depend on what you need to depend on, and everything else is given to you because you can layer them. So, and by the way, they started with Linux, and now Microsoft has Windows containers as well, so they can be Windows processes as well. So you have Linux containers, Windows containers. In this talk, we are talking about ASP.NET Core running on Linux, so we are talking about Linux containers. But you can also take traditional ASP.NET and put it in a Windows container as well. And that's already happening on Windows Server. All right, and then the main one that's used today, the main container platform is Docker, but there are others like Rocket from CoreOS that you can use as well, okay? So why containers? So if you look at what we used to do before, we used to have a physical machine that has the operating system, and we had the libraries, and on top of the libraries, we built our applications, right? So that's what we used to have. The thing about this is that anytime something changes with the kernel or anytime something changes with the libraries, you could break the apps. So there was this tight coupling between your environment and your applications, and that wasn't good, right? Then came along virtual machines. So with virtual machines on the same physical machine, you could have many virtual operating systems. In this case, you can wrap your operating system and your libraries and your app into this virtual machine. And this gave you the isolation that you needed. But the problem in this case is that instead of dealing with one kernel, you're dealing with 4 kernels. So they weren't lightweight, they were heavy. So most people use them for, at the deployment time, they wouldn't actually use them when they were building their application because they weren't lightweight enough. Now containers, they give you the kernel, so everything runs on the same kernel, but then you put the app and the dependencies of the app, the libraries, into a container. And the good thing about the containers, they're really fast, they're really easy to start with, so people use them in development as well. So you develop in containers, you deploy in containers, you run in containers in production as well. So you have the isolation, but you also have the lightweight environment that you need. So that's why containers are important and they are useful in running applications in production. And even though containers might look like they're new, at Google we've been running them for over 12 years. So for a long time we've been running them. And everything at Google, like Gmail, MapReduce, even the Google Cloud Platform, the virtual machines in Google Cloud Platform, they run in containers. And we launch more than 2 billion containers per week. So you can see the scale that we do at Google. So now let's take a look at our microservice that we just built and try to see how we can containerize that. How can we run it in Docker? So let's take a look. So here I am again in Cloud Shell. I have my application that I just showed you before. Now what we're going to do is we're going to get our application and all of its dependencies into a single DLL. So to do that, we'll do .NET publish-c release. So this will compile my application, get all of its dependencies into a single DLL, and that way I can use that DLL from Docker. So from Docker, we're going to say, just run this DLL. So we do the publish, and this will publish our DLL. So once this is done, we need to build the Docker image. To build the image, we need a file called Dockerfile. So Dockerfile kind of defines how your image is going to look like. So we'll create the Docker file and define our image in that file once this is done. So this should take like 10 seconds. All right, so we have our DLL. So we'll go into the publish folder. And I already created a Docker file before, so I'm just going to copy that Docker file into this publish folder, and I'll show you how that Docker file looks like. So we'll just copy the Docker file. Yeah, and then let's just take a look at the Docker file and see what it means. So if you look at the Docker file, it's quite simple. The first line says from Microsoft.NET 101 runtime. So remember, I told you that you can have images that depend on each other, right? So in this case, I'm basing my image on Microsoft's .NET runtime image. This is my environment, okay? And then I'm copying my current folder, the DLL folder, to the app folder in the container. And I'm setting my working directory to the app folder. So when my container starts, it will start from this app folder that I defined. I'm exposing port 8080 because that's the port that my app is going to run. And I'm also setting an environment variable called ASP.NET Core URLs. So this will make sure that my ASP.NET Core application will start on port 8080. And then the last line basically says, when the container starts, what should I do? We will just do .NET and point to our DLL. So the DLL that we just created, we'll just point to that and we'll just run that. So basically with this one file, we define our dependencies and we define our environment here, and we are starting our .NET application. So once you have this file, you need to actually build the image. So to do that, we'll do Docker build, and then it's a best practice to tag your image with some information. So in this case we are tagging it with Google Cloud Repository. This is the name of my project, and this is the name of my image that I chose, and then this is the version. I'm giving it a version number as well, so I'll just call this version 1. So what this will do right now is it will first look at the Docker file and look at the dependencies. It will pull the image that it depends on. So in this case, it's depending on Microsoft.NET runtime. So it's pulling that image, and once that image is downloaded, it will go through the other steps that we specified, right? So I'll fast forward this so we don't have to wait, because we don't have that much time. But once this is done, so once this is done, what you have, if you do Docker images, you have two images, the base image that you depend on and the image that you just created. So we created our image. Now, to test that this image is actually working, what we're going to do is Docker run. -D means run in the background, so don't hold the console. -P means port, so expose port 8080 in the container to port 88 on my machine. And then I'll just point to my image that I just built. So I'm basically running the image that I just built. Now this is the hash of the image. Now the image is running. If I do Docker PS, now I can see that my image is running, and then if I do a web preview, I will see the same map again. Nothing fancy, but the difference in this case is that our application is not running on the machine, it's running in the Docker container as Docker image, okay? And then you can say Docker stop, and then pass in the ID, and then this will stop the container. Now, if my app is not running anymore, if I do Docker PS, I won't see my app. And the last thing I want to do is I want to use this image in Google Cloud. So to do that, I'm going to push this image to Google Cloud repository. There's a repository where you can push Docker images. So here I'm doing gcloud docker push and just pointing to my image. This will basically look at the image on my machine and it will push it to Google Cloud repository. This is important because later when I create a Kubernetes cluster, I'm going to refer to this image. So this is a place where I just put my image. That's the beauty of Docker, is that once you build your image, you can put it on Docker Hub. You can put it on Google Cloud repository. You can put it anywhere you want, basically. So we won't wait for that because we don't have time. So we built our microservice and we containerized it and we pushed the image to Google Cloud, okay? Now, containers are good because they give us the environment that we need for our application to run. So I can run the same image on my laptop, it works the same way. I can push it to Google Cloud and run it there, it works the same way. So that's great, but they're not enough, right? So let's say you want your application to be resilient. So your app is running and it goes down. Who is maintaining that? I mean, who's gonna start a new one? You have to do it, right? If you want your app to be redundant, so let's say you want to have multiple copies, who's going to do that? You have to deploy multiple copies. And since you have multiple copies, you need a load balancer to load balance between them, right? So who's going to do that? You have to do that. If you need to deploy a new version, you have to figure that out. If the version that you deployed is not working, you need to roll back, right? There's all these things that you still have to do. And Docker and containers, they don't help for this, right? So that's when Kubernetes comes in. So Kubernetes, the goal of Kubernetes is basically to help with all these container problems that you need to deal with in production, okay? That's the whole thing. So the name Kubernetes, everyone says it's Kubernetes, but it's actually Kivernetes. It's because it's Greek. But since the name got stuck, everyone now calls it Kubernetes. As I mentioned, it basically helps you to manage container clusters. It's 100% open source, written in Go. It's one of the most popular projects on GitHub. The coolest thing for me about Kubernetes is that it supports multiple cloud providers. So you can run it on Google Cloud, you can run it on AWS, you can run it on Azure, you can run it on your own machines. You can even have a Kubernetes cluster that spans them. So you can have a cluster that spans Google Cloud and Amazon, or you can have Google Cloud and your data center as well. So that, for me, that's really great. And it's an open source project, but it came from something called Borg. So at Google, as I mentioned to you, we've been running containers for 12 years, and we created this internal tool called Borg. So people who worked on Borg, they looked at it, they learned from it, and they created Kubernetes. So it didn't come from out of nowhere, it came from Google internal tool Borg. All right, so at the very high level, this is what you have at Kubernetes. You have the master that manages the cluster. You have the nodes where you actually schedule the containers. The master and the nodes, they talk through something called kubelets. And as a user, you basically talk to the master. So you talk to the master through API, through CLI, or through UI. So as a user, you basically don't really care about the fact that there's a master even. All you care is this API that I'm going to show you. You talk to the cluster through the API, and that's all you really care about. So when you set up a cluster, there are two steps that you need to do. First, you need to set up the cluster. And these are the steps. So this is when you want to actually set up your own Kubernetes cluster. So you need to choose a cloud, you need to choose a node OS, you need to provision machines, you need to configure networking, all that kind of stuff. Or you can use something called Google Container Engine that basically with one command gives you a Kubernetes cluster. So that's the part that Google Container Engine provides. It basically hosts Kubernetes for you, and with one command you can get a Kubernetes cluster. And so if you want to use Google Container Engine, this is how it looks like. You, in Cloud Shell that I showed you, you create a Docker file, you create an image, you push it to Google Container Registry. From here, you tell to Google Cloud using gcloud, give me a Kubernetes cluster with this many nodes, and it gives you a cluster within like 2 minutes. And then after that, you have a cluster, and then you can use something called kubectl, which is a command line tool to manage Kubernetes, and then talk to your cluster. So that's how it looks like. So let me just show you quickly how to create a cluster using Container Engine. So here I am again in Cloud Shell. We pushed the image. Remember in the previous demo, we pushed the image. Now if you look at the go to Google Cloud Container Registry, under here you see we have our image, hello.net, and under there there's a version 1. So this is my image that's already in the cloud. Now what I'm going to do is I'm going to create a Kubernetes cluster and tell it to use this image. So what I'm going to do is I'm going to say gcloud container clusters and create and give it a name. So I'm going to call it hello.net cluster. And then now you can say how many nodes. So how many machines do you need to in this cluster? So all I'm saying is the number of nodes is 1. So in this case, I just want 1 machine, but you can have as many as you want. And then you can specify the machine type. So how big are these machines, how many CPUs and things like that. So I'm just using standard machine. And I'm setting zone as Europe West. So this is going to be created in Europe West. So this is the command that it takes to create a Kubernetes cluster in Google Cloud, okay? This will take a couple of minutes. But once it's done, we'll see it here. So I'll just, again, fast forward because we don't have that much time. But if we go here, eventually it will show up. Yeah, as you can see, it shows up. And then it says, this is my cluster. And then you can use this cluster, OK? That's all it takes. All right. So we have our cluster now. Now we can use a cluster. So let's talk about using the cluster. What are the building blocks that Kubernetes gives you now for your application? So that's what I'm going to talk about right now. At the very high level, this is what a Kubernetes cluster looks like, right? The first thing is something called a pod template. So a pod is usually a container, or it can be a group of containers. I'm going to talk about it shortly, what it means. So you create a template for your pod. And then you create something called replication controller. So replication controller is the guy that helps you to maintain the state that you want to maintain. In this case, we are saying, I want to have 3 pods, and I want them to have these labels. So what replication controller does is that it looks at the pod template, and from there, it figures out which image to use, okay? And then it creates 3 pods with these labels, okay? Now, under the covers, these are the nodes where these pods get scheduled, but as a user, you don't care. You don't care about machines anymore. All you care about is the pods, the actual application that you created. All the scheduling on the nodes, it happens through Kubernetes, okay? Once you have your pods, you want to expose them to outside world, so you create something called a service, and then a service is kind of like a load balancer, basically, that exposes your service. So your service becomes this, basically. So this is your microservice. So your microservice in this containerized world in Kubernetes is basically a combination of replication controller, your pods, your services that you expose, that gets scheduled somewhere in the nodes that you define, but you don't care where or how, because that's what Kubernetes does for you. You don't care about that as a user. The first thing that Kubernetes provides is called deployments. So deployment is kind of like the high-level object that you create initially that creates everything under the covers. So it creates the replication controller, it creates the service, it creates the pods, and all that kind of stuff. But you start with deployments. So deployments is the thing that you start in Kubernetes with. So let's just look at how to create a deployment in Kubernetes. Okay. So here I am again in Cloud Shell. We have our cluster, we have our image in the cloud. what I'm going to do is I'm going to create a deployment that will use that image. So what I'm doing here is I'm using, first I need to authenticate my Cloud Shell with the cluster. So to do that, I just run one command. But this is just a detail that you don't care about. So what I'm going to do is I'm going to say kubectl and run hello.net. So this is the name of my deployment. And then I'm going to refer to this image. So this image is the image that we pushed earlier. So all I'm doing is I'm basically telling Kubernetes, create a deployment and use this image as the app, basically. So once we do this, and then you need to also expose the ports that you need. In this case, it's port 8080. And then it says deployment is created. So if you do kubectl get deployments now, we'll see that our deployment is already created. And then we can do kubectl get pods. So these are the lower level things that gets created by deployment. So it says continuous creating. So the pods are getting initialized. And if we do kubectl get pods again, now it's already running. So as you can see, it's really fast. Within seconds, you have things running. If I do kubectl get replica sets, I see that my replica set is also created. And then if I do kubectl get services, this is the guy that will expose my pods to the outside world. But right now, I don't have an external IP. I have to do that myself because we don't want things to be exposed to the world by default, so it's not there yet. So with one command, we created our deployment and things are running. Next thing I want to talk about is the pods. So as you've seen, the deployment created the pods. So what are pods? Pods are basically the logical units, the smallest unit that Kubernetes uses to schedule things. So in this case, for example, we have a pod that has two containers. One container is, let's call it like file puller that pulls some files from some place. And then another one, let's call web server that exposes those files to some consumers. So these are two containers, and they're sharing a volume. So this is like the storage for my containers. And I put these in a pod because I want them to live together and I want them to die together. So if file puller goes away, I want the web server to go away as well. So because of that, I put them in what's called a pod, and Kubernetes uses this pod to schedule things together all the time, okay? So that's what a pod is. And then the volume is basically a pod scope storage. So it's the storage for the pod that lives with the container. So when the container is gone, the storage for it is also gone, all right? So once you have your pods, you can label them. So you can attach key value pairs to your pods. In this case, for example, I have a label called app that has a value my app, and then I have another label called phase and role. And the cool thing about labels is that once you label your pods, you can access them using these labels. So you can say, give me all the pods that's all of my app. So this will give you all the pods. If you want to say, give me all my apps that are the front-end role, you can say app equals my app and role equals front-end. If you want to get the back-end ones, you can do that. If you want to get the production ones, you can do that. If you want to get the test ones, you can do that. So by labeling your pods, you basically group them in any way you want. So let's talk about replication now. One of the problems in running software in production is that you want to make sure that things are running. And if something goes wrong, if a container goes down, you want to make sure that a new one gets started and then it's running again, right? So in Kubernetes, you don't have to worry about this because there's something called replica sets. So you create a replica set and tell it what you want it to be true, and it will make sure that that's true. So in this case, for example, I have a replica set for my app, and then it's using this template that I defined. And then I want to make sure that it has 4 replicas, so 4 pods running all the time. So what this guy will do is that it will basically query the API server in Kubernetes, and it will make sure that all the time there are 4 pods running. If at some point we had 3 pods because the node went down, it will make sure that a new pod gets created and assigned to another node, okay? So in this case, for example, I want my replica set with 3 pods, and the labels is app equals demo, and color can be blue or gray. So in this case, as you can see, I have 3 pods with they all have app equals demo, and then some of them have color blue and some of them have color gray. Replica set will make sure that that's the case, okay? So I want to show you the replication, but we don't have time, so I'll skip that. But we can cover this later. I'm going to be around if you want. So once you have your replica sets and your pods running, you want to expose your pods to the outside world. For that, you create a service. So in this case, I'm creating a service with this label and then all the pods that have that label, they're exposed to the outside world, basically. Let me show you the service demo quickly. So here I am again. I have my deployment. And then I have my pods running. And I want to expose this pods to the outside world. What I do is I do kubectl expose deployment hello.net. So I want to expose this hello.net deployment, and I'm going to use type load balancer. So this says expose this, deployment behind a load balancer that's public to the world. So this says the service is created. So if we do kubectl get service, as you can see, I have a service that has an internal IP, but it doesn't have an external IP yet. It's pending, all right? So I need to fast forward a little bit, because what's happening right now is that Google Cloud is creating a load balancer, and it will attach that load balancer to this Kubernetes cluster. So it will take a couple of minutes, but we don't have time. So if I go forward, at some point it gets an external IP, all right? And if I go to the external IP, yeah, if we go there and do port 8080, we will see the same app again running in the cloud. The app is not fancy again, it's the same app, but the difference is it's running within Docker, in the cloud, managed by Kubernetes, okay? There you go, okay. Now, in the last 2 minutes of the talk, I'm gonna go really fast so that you know that there are things that exist, but I won't explain them what they are, because we don't have time. But feel free to come to me after the talk and I'll explain more. So there's a dashboard that you can take a look at, okay? That's it, no demo. There's scaling, so if you need to scale, let's say you have a replica set with 3 pods, you want to have 4 pods, what do? You go to replica sets, change 3 to 4, and you have scaling. It's so easy. Demo, but we can do that. Rolling update, so if you want to update your app from version 1 to version 2, how do you do it today? One way of doing it is that you can just kill this, create a new one, and then that's it, right? But that's not the right way. The right way is to create a new one, add a new version, take one out, add another one, take one out, add another one, take one out, and when everything is working, take this guy out. Kubernetes basically helps for this. With one command, you can do rolling updates, and it does it this way automatically for you, so you don't have to do it yourself, okay? Rolling update, there's a demo if you want to see later. You can do canary deployments, so you can set 2 replica sets with 2 different versions of your app, and then you can put them behind this single service. That way you can do canary deployments and test that version 2 is working as it's supposed to work. There's auto-scaling, so it automatically scales, basically. There's daemon sets, there's jobs, there's stateful sets, there's config maps for configuration, there's secrets for secret stuff that you want to get attached to your pod. That's possible, and there's even more, okay? So this is just really, really high level of what Kubernetes provides. If you want to know more, there's kubernetes.io. If you want to know more, Container Engine is here. If you have any questions, feel free to reach out to me, and if you have any talk feedback, this is the link. Thanks very much. Okay, good.
Ребята, у нас есть время на вопросы.
Hi, thanks for the talk.
Yep.
One question: migrations. How? Database migrations.
Database migration.
Yes.
So first of all, you don't put usually databases in a container. You put that outside the container, and your pods access that database using the API that the database has, right? So you just migrate your database the way you migrate today. Kubernetes doesn't really provide anything for that.
Another question. Thank you for the talk. How do you do configuration management using Kubernetes and containerized applications?
So there's something called, I wanted to talk, but we didn't have time. There's something called config maps. You basically define your config map in a central place, and then that gets attached to your pod as a volume, and you can access the config map from there. So that's for regular configuration. If you have sensitive information, there's something called secrets. It's the same way you define it in a central place, and it gets attached to your pod as it gets created. So that's how you do it.
And what interface do you use? Is it a HTTP API or database or something? How to get the configuration items?
Oh, it's like an environment variable, basically. So you just define that in the secret or config map, and then you refer that environment variable from the app itself. Yep. One more question? Yep.
Hello. I have a question about kernel and virtualization in container. Can you say how it will be? I have an application, I have a Docker container with this application, and I can. You said that I can run Kubernetes on bare metal devices.
Yes.
So I can run in cloud this application, and can I run this on bare metal Windows servers right now?
So yes, so the containers, they came from Linux, but recently Microsoft also started supporting Windows containers. So you can have a Windows container, it's called like Windows Nano, or a small version of Windows basically, and that can be run within Docker.
And I can run Kubernetes cluster on Windows right now, yes?
Kubernetes on Windows itself, it's 90% there. There are certain things that don't work yet, but it's 90% there. So within like next few months, I think it will be fully supported. Yeah.
Thank you.
Yep. By the way, I have some Kubernetes stickers, so if you want some, come and grab them. Thank you.
One more question.
One more question, yeah.
Yeah, thanks for the talk. Tell several words about the service discovery, how it's done in Kubernetes. Whether it's done via services you mentioned or...
No, services help you to load balance your pods, but there's also a service discovery mechanism in Kubernetes that you can use. I didn't cover it in my presentation, but there is such a thing.
Okay,
Yep.
thanks.
So the question is, thanks for the talk. The question is on Azure or on AWS, do services use ALB or Azure Load Balancer or so? And if I run it on a bare metal, which network and which load balancer does it use? So do you like, yeah.
When you run it yourself, it's basically up to you to configure it in your environment. And if you go to Kubernetes website, they basically tell you the steps that you need to take to configure it yourself. So that's that. With Azure and AWS, I don't know exactly what load balancer it uses. I mean, it probably uses whatever Azure has for load balancing, like Traffic Manager or something like that. But I haven't done it myself, so I wouldn't know. In Google Cloud, it's using basically Google Cloud's HTTP load balancer. And all of this stuff is quite pluggable. So if it's using something that you don't want, you can plug in whatever you need to. That's the whole philosophy behind Kubernetes, is that things are pluggable.